Hello everyone, my name is Aneta and this is Chemistry at Glance. This is another video on chemical calculations. If you're not happy with the quick last-minute revision explanation here, you can visit my blog. I leave the link in the description box below for the full explanation, full tutoring on this topic, together with a link for past paper practice questions on this topic as well. Today we're working on the percentage yield. And again, let me just write the equation first. So, theoretical percentage yield is all about the theoretical mass and the mass of the product that we actually obtained. So in an experiment, you get a mass of something that's produced, so the mass of products. However, in your textbooks, it says what the mass should actually be. Or maybe not in your textbook, but according to the number of moles, you can calculate what the mass should be, and then you compare it with the mass that you actually got. You multiply it by 100, and that's your percentage yield. Let me show you an example. So here's the question. Ethene C2H4 can be obtained by dehydration of ethanol. Here's the equation for this dehydration. And now you're told that 0.5 grams of ethene was obtained from 5 grams of ethanol. And what is the percentage yield? So, first of all, we had 5 grams of ethanol. From the experiment, we know we got 0.5 grams of ethene at the end. So that's our mass of product obtained. Now we have to find the theoretical mass. So in the experiment we got 0.5 grams of ethene. However, theoretical mass is the mass that we should actually obtain if there wasn't any products lost or anything like this, or any errors. Okay, so how do you calculate the theoretical mass? How do you do it? Is you just do doing a calculation on reacting masses. So if we had 5 grams of ethanol, we know the MR, we can use this equation to find the number of moles. Why do we find the number of moles? So that we can find the molar ratio between ethanol and ethene. So the number of moles of ethanol is mass, which is 5 grams, over the MR of ethanol, which is 12 times 2, plus 5 times 1.01, plus 16 plus 1.01. So the number of moles that we finally get is 0.1 moles. Because the ratio between alcohol and alkene here is 1:1, they both have the same number of moles. So ethene will also have 0.1 moles. So now we're trying to find the mass of ethene that should be formed. So we rearrange our equation to find mass. So MR was divided on this side, so it's multiplied on the other side. Number of moles is 0.1, is the ratio. And we multiply by the MR of ethene, which is 12 times 2 plus 4 times 1.01. And the mass that I got is not 3.0844 grams. So this is the mass that we should get if we had the right conditions, and this is the mass that we actually got in the experiment. So our percentage yield is the actual mass, 0.5, over the theoretical mass, 3.0844, multiplied by 100, which gives you 16%. Again, as you can see, this percentage is very low, so percentage yield is very, very small. And what that means is making ethene from ethanol is not very effective. And what I mean by this is that making ethene, we should make ethene from something else, not ethanol, because we don't get much ethene from ethanol anyway. So again, 16% is a small number, so something must have went wrong in the reaction, because what you should get is as closer number to 100 as you possibly could. So if you only got 16%, that means that something in the experiment went wrong. You lost some reactants, you lost some products, something was lost or wasn't enough of it. That's why your percentage yield is low.